Okay, so today we are going to start concepts of phasor and idea about different kinds of power. So let's first look at concept of phasor. So now in general we denote a signal as Vt equals Vm sine omega t plus phi. Note, whenever you're discussing signals, you can either choose sine or cosine. Be consistent with your notation. Always use one type. Either use sine or either use cosine. If you use cosine, if you use sine but the question is given in cosine, what you can do is always change the phase factor. Now, a shorthand way of representing the same thing would be Vm angle plus or minus phi. This can be plus or minus. Now this is represented in the form of peak to peak. However, it can also be represented as Vm by root 2 angle plus or minus phi in case of RMS. Okay. So now whenever you are going to compare two phasors, there you must keep in mind three things when comparing phasors. Both should have same function, as in sine or cosine. Both of them should have the same frequency. And both of them should have the same amplitude. Not amplitude, sign. As in, both of them should be plus Vm sine omega t plus phi. You cannot compare plus and minus, although you can, but it will be simpler if you can just choose the sign to be the same. Now always remember that if a phasor is is moved in clockwise direction, then it's lagging phase, and when it's moved in the positive direction, it's in when it's moved in the counterclockwise direction, we have positive sign of the magnitude, and it's leading the base. Okay, so to get the concepts clear, we can maybe compare a few phasors. Say x1 equals phi sine omega t plus 60 degree, x2 equals minus 5 sine omega t minus 60, x3 equals say plus 10 cos omega t minus 70, x4 equals minus 10 cos omega t plus 40. So whenever you're drawing these phasors, it's actually useful to denote just a second. it's usually useful to take base vectors. As in this case, what we can take is this to be plus sign, which will make this as minus sign something. Let's take omega t plus 0, minus sign omega t plus 0. So this will obviously be cos omega t plus 0, and this will be minus cos omega t plus 0. Okay, so the first one is 5 sine omega t plus 60, which means when you take the positive sine omega t, it's leading by 60 degree, right? So what you can do is, leading is anti-clockwise, right? So what we can do is, from sine omega t you can draw a vector somewhat like this, which is at an angle of 60 degrees, and this is our x1. Now x2 is minus 5 omega t minus 60. So in the minus sign axis base vector, we can take the phase to be minus 60. Remember, minus implies that we have to go clockwise. We go clockwise 60 degrees from this thing, this vector, and we should also keep in mind the magnitude. So let's say something like this. Okay, this angle is 60, so this would be x2, and x3 is lagging 70 from positive cosine axis. So lagging as in clockwise, so we'll move positive 70 degree with a magnitude of twice the magnitude of x1, say this thing. So this will be x3 with this angle as 70, and x4 will be leading minus cosine base vector by 40 degrees. This is our minus cosine vector and it's leading, so we'll go counterclockwise by 40 degrees. Oh, and we should also keep in note the magnitude, in which case it will be something like this, and this will be x4. So by drawing this representation, you can easily solve any kind of numerical concerning comparison of two phasors. For example, if you want to compare x1 and x3, so x1 is leading x3 by so this is 70 and this is 60, so this will be 40 degrees. And we can say x1 and x2, if you are comparing, x2 leads x1 by 60 plus 70 plus 90 to 20 degrees. Or in other words, you can also say actually you can say lags x1 by 140 degrees. That's a better word. So this is how you can compare phasors. So next we'll look at different types of power that we generally come across. Not different types of power, but the different notations that we come across. So instantaneous power P of t equals V of t times I of t. Now V of t will be equal to Vm sin omega t plus phi 1, because I can be phi 2 sin omega t plus phi 2. Now with some basic algebra, this will turn out to be Vm Im by 2 times cos of theta 1 minus theta 2 phi 1 minus phi 2 phi 1 minus phi 2 plus cos of 2 omega t plus phi 1 plus phi 2. So now this Vm can be represented as this factor. Since this is divided by 2, we can split the root 2 for each of these, then get it as Vrms Irms times this thing. So this cos theta cos phi 1 minus phi 2 is called the phase power factor, and that's one way we can represent instantaneous power. And this whole term Vrms Irms cos phi is called P average. Now this P average is also sometimes called as DC power. Now let's look at something known as complex power. Now complex power is Vrms times Irms with a conjugate, and we can represent this as P plus or minus J cube. So this factor will become Vrms magnitude times angle phi 1 times Irms magnitude times since we are taking the conjugate, we have a negative sign of phi 2. Now this again comes out to be Vrms magnitude Irms magnitude phi 1 minus phi 2, which can also be written as Vrms cos theta 1 phi 1 minus phi 2 plus J times Vrms Irms sin theta 1 phi 1 minus phi 2. Now this is basically just polar to Cartesian form. So you can see this whole is the real power and this whole part is the complex power. And the apparent powers P apparent is given by VRMS times IRMS. One more thing to be kept in mind is when you are taking power of an element, say a resistor, with I and V, the power is VRMS IRMS times cos phi, where phi is always the relative phase difference, a phase difference of these vectors I and V, and phi is always the angle relative to V, and it's not any other difference. Well, that's all for today. We'll continue with transformers in the next class.